Hello and welcome. We're going to do Mathematics Advanced Level Mechanics paper, June 2025. Mechanics, June 2025. So for this question, it's important you try it first before you look at the solution. So a car moves in a straight line along a horizontal road with a constant speed of 2 meters per second squared. The car is moving with speed 15 meters per second in the direction of the acceleration when it passes a signpost on the road. The car is modeled as a particle. Use the model to find the speed of the car 4 seconds after passing the signpost. So you write down the sievert, and you know U is 15 meters per second, which is given there. It's the initial speed is 15 meters per second. The acceleration is 2 meters per second squared, and the time is 4 seconds. So you use V equals to U plus AT. U is 15, A is 2, and T is 4. You work that out, it gives you 23 meters per second. Figure 1 shows the horizontal force acting on the car. Given that the car has a mass of 800 kilograms, the driving force of the engine has a magnitude D newtons. The resistance to motion of the car has magnitude 40 newtons. The acceleration of the car is 2 meters per second squared in the direction of the driving force. Use the model to find the value of D. So highlight those numbers. It makes it easier for you to look at them when you want to start solving the question. So we're going to use F equals to MA. Force equals to mass times acceleration. The force, the unit is in newtons, capital N. The mass, the unit is kilograms. And the acceleration meters per second squared. Acceleration is a vector. Mass is a scalar. It only has size. Acceleration is a vector. It has the magnitude or size, and it has direction as well. Size and direction. Force is a vector. It has size and direction. So we write F equals to MA. So the forward force is D, pulling it forward, and the friction pulling it backwards is 400. So forward force, total forward force minus total backward force is equals to the mass times acceleration. The mass is 800, acceleration is 2. You rearrange that, you get G is 2000 Newton. So this is what you need to memorize. Forward force minus backward force. It gives you what they call the net force. And it is the net force that does the acceleration for that object. That gives the acceleration. So memorize it. Forward force minus backward force is equals to mass times acceleration. Very important to learn that. Question number 2. A small box B of mass 2 kilograms is dragged in a straight line along a rough horizontal plane at constant speed by a force of magnitude 5 newtons. The line of action of the force makes an angle alpha with the plane, where sine of alpha is 3/5. As shown in figure 2, show that the magnitude of the normal reaction of the plane on the box is 16.6 newtons. To show this, we will draw the diagram and label the forces acting on the box. There's that upward force there, which is the reaction. In physics, they'll call it N, normal reaction force, but in mass, we use R. There's the weight acting downwards. The weight is mg. Remember, weight is different from mass. Weight is mg. So 2 times g, and g is 9.8. And there's the friction force acting to the left, opposite motion, and the 5 Newton is pulling it to the right. But we have to resolve this 5 Newton force because it's at an angle of alpha. So we can resolve it to get the horizontal, which will be 5 cos alpha, and we get the vertical, which is 5 sin alpha. So when we resolve the thing vertically, how many forces are going up? 1, 2. So 2 forces are going up. How many is going down? 1. So resolving vertically, total upward force is this R plus 5 sine alpha is equals to the downward force is equals to 2g. And the reason why they're equal is because the object is not moving up or down. It is in equilibrium. But when it is equilibrium, it's not going up or down. It stays where it is. The upward force is equal to the downward force. So the upward force is R plus 5 sine alpha is equal to the downward force, equal. So sine alpha is 3 over 5. You solve that, you get R is 16.6 newtons. At the instant when B is at the point O on the plane, the force of magnitude 5 Newton is removed. Describe the motion of the box after the force of magnitude 5 Newton is removed. So friction is acting in the opposite direction, acting towards the left. When you remove the 5 Newton force, there's nothing pulling it to the right. So the thing will start to decelerate. Decelerate, it means the velocity will be slowing down, reducing and changing and slowing down. And it will be slowing down at a constant rate or uniformly, equally, until it comes to stop or rest. So the velocity will decelerate, the acceleration will decelerate, and it will slow down. Eventually, it will come to rest or it will stop. So if you're understanding the work and you're enjoying the explanation, please feel free to WhatsApp me for more private tuition, or you can send me an email. And if you want to see more videos like this, you're always welcome to donate to the channel. That will help give me more time and help me to make more and more videos like this to help you. So you can click on the link and donate, and that will give me time to make more and more videos like this in great detail to help students. And you can also contact me for private tuition. Find the magnitude of the normal reaction of the plane on the box after the force of magnitude 5 Newton is removed. So you can see here on the right hand side, the force of magnitude 5 Newton has been removed. It's not there. So what do we have left? We have, so remove F. So resolving vertically, we have the upward force R is equal to the downward force 2G. So the magnitude of R is that 19.6, which is 2 times 9.8. It's 19.6 Newton. Given that after the force of magnitude 5 Newton is removed, the box is modeled as a particle. Air resistance is modeled as being negligible. So remember all these things that you're using. They are things that you're assuming before you can solve the question. The coefficient of friction between the box and the plane is modeled as 0.2. The speed of the box as it passes through O is 4 meters per second. The box comes to rest. When it comes to rest, the final velocity is 0 at the point X on the plane. Use the model to find the length OX. So we have the reaction is 19.6 newtons. Force of friction is mu R. And so it's 0.2 times 19.6, it gives you 3.92 newtons. And then as force is equals to mass times acceleration, acceleration is force over mass. And we call it deceleration because it is slowing down. It is slowing down. So the deceleration is 1.96. So we should put a minus there because it's slowing down. It's minus 1.96. So we would say the acceleration is minus 1.96 because it's slowing down. So we put the SUVAT, SUVAT. Let me show you the SUVAT equations again. So these are the SUVAT equations. V equals to U plus AT, V squared equals to U squared plus 2AS. So you need to learn them, but they are given in the formula booklet. So you learn how to use them. Frictional force, you have to remember it is mu times R. Mu times R. So we would have the initial speed is 4 meters per second. Because it comes to rest, the final speed is 0. The acceleration is minus 1.6 because it's a deceleration, it's slowing down. So we have U, V, and A. Which of the formula has U, V, and A in it? This is the one. V squared, U squared, and A. So the length of OX is S now, the distance. So you rearrange it to make S the subject. V squared minus U squared over 2A. V squared is 0, U squared is 4, A is minus 1.6. Solve that, you get 4.08 meters to 3 significant figures. For part E, state one limitation of the model, apart from ignoring air resistance that could affect your answer. In the question, you treat it as a particle. So a particle does not rotate. If something is moving, it rotates. And then the friction coefficient can change. The friction does not stay the same. It can change. So we didn't consider that. And plane assumed perfectly horizontal. The surface may not be horizontal. It may not be flat. It may be bumpy. There may be small bumps. We assume the mass is constant. The mass may be changing. The box may have deformation, and that will affect friction as well. So you can choose any one of these 5 things. The rotation of the box, frictional force, the surface may not be horizontal. Question number 3. A particle P of mass 0.5 kilogram moves with constant acceleration on a smooth horizontal plane under the action of a constant horizontal force. So do not forget to subscribe to see more videos like this when I make them, and contact me for private tuition. Thank you and good luck.